Hello, good morning, good afternoon, good evening. This is the lesson for Unit 2, Lesson 2, Angles and Parallel Lines. Our essential question is, how do angles help identify relevant measures in real-world situations? This image is a perfect example of angles and parallel lines and transversals that we've been talking about. Objectives: use theorems to determine the relationship specific pairs of angles. Use algebra to find angle measurements. Parallel lines with transversals. Let's get into it. So here we have a couple parallel lines with a transversal. So in this case, the given would tell us that A is parallel to B. And we would say that L is a transversal. And what does that mean? Well, here's the special part, all right? If we say that A and B are parallel, so we can actually make them parallel by putting these little indicators on there, then what we know is that the intersection at each of those parallel lines are actually going to be identical, okay? Oops. So these are identical intersections. And what that means is that if we notice that we have say a obtuse angle here and an obtuse angle here, both those angles are going to be congruent. Both these angles are going to be congruent. This angle is going to be congruent to this angle, and this angle is going to be congruent to that angle. And essentially, we can take both of these indicators and we can kind of condense them together. And we'll notice that they are both identical. So let's use this and use the special angle pairs that we talked about in the last lesson to identify some very important key features of these. So let's talk about parallel lines and angle pairs, relating angle positions. So we have corresponding angle postulate. This is something that we need to just accept as true. The corresponding angles postulate tells us that if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. Therefore, we can see that we have corresponding angles 1 and 3, and we can say that they are both congruent. Angle 1 is congruent to angle 3. But we can also match the rest of the corresponding angles and tell us that angle 2 is congruent to angle 4, angle 7 is congruent to angle 5, angle 8 is congruent to angle 6. Look at how each of them operate. Corresponding angles means that they are in the same position on different intersections. But in this case, since the lines are parallel, it means that the corresponding angles are the same. They are congruent, and therefore they are equal in measure. So let's use this idea to answer a few basic questions. In the figure, the measurement of angle 11 is equal to 51. So if we look at angle 11, let's see that we have angle 11 here, and we have angle 15. Well, we know that angle 11 is congruent to angle 15 because they correspond. They are corresponding angles, and therefore we can actually say that the measure of angle 11 is going to be equal to the measure of angle 15. And so, therefore, we can say that the measure of angle 15 is equal to 51. We already know that x is parallel with y. And so if we know that, then we can say that they're corresponding angles. So now let's we're looking still at angle 11, but we can look at angle 16. Now, we've already said that the measure of angle 11 is congruent to the measure of angle 15. Equal to, because of the corresponding angle postulate. But we can also say the measure of angle 15 is equal to the measure of angle 16 because they're vertical angles. And that was a theorem. Well, if we know that 15 is equal to 16 and 11 is equal to 15, then essentially we can say that the measurement of angle 11 is equal to the measurement of angle 16. And so therefore, we're going to say that the measurement of angle 16 is equal to 51 as well. So let's take a look at another pairing. We have alternate interior angle theorem. If two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. So let's take a look at these alternate interior angles. As you can see, they both look like they're obtuse angles. If they look like they're obtuse angles, then they probably are both obtuse angles, in which case if these lines are parallel, then they are going to be congruent. And so we can also see that angle 2 and angle 4 will also be congruent as well. Consecutive interior angle, the theorem states that if two lines are parallel and they're cut by a transversal, then each pair of consecutive interior angles is supplementary. Now let's take a look at both of these. That tells us that angle 1 and angle 2 added together are equal to 180, and angle 4 and angle 3 are equal to 180. And so you can see that they aren't the same. One looks obtuse and the other one looks acute. They are not in the same position, but we can tell that if I go like this, if I say that, oh, this is equal to angle 2, well, these essentially are a linear pair, 1 and 2. So both of these have to be equal to 180. Okay? So consecutive interior angles are equal to 180. And then we have alternate exterior angle theorem, which states that if two parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent. And therefore 5 and 7 would be congruent, and 6 and 8 would be congruent. So 3 out of 4 of these pairings are going to be congruent. The only one that's not is going to be the consecutive interior angles, the same side interior angles. So in this case, making parallel lines. Ryan is designing a pattern that involves adjacent parallelograms. If the measurement of angle 2 is equal to 125, find the measure of angle 1, 3, and measurement of angle 4. Explain using geometric vocabulary. So we know for a fact that this angle here is 125 degrees. Well, we do know that the measure of angle 1 plus the measure of angle 2 is equal to 180 because they are a linear pair. That tells us that the measure of angle 1 is equal to 180 minus 125. So the measure of angle 1 is equal to 55. We can also say that the measure of angle 2 is equal to the measure of angle 3 because of the alternate interior angle theorem. So therefore we can say the measurement of angle 2 is equal to the measurement of angle 3 is equal to 125. And finally, we can say that the measurement of angle 1 is equal to the measurement of angle 4 because of the alternate exterior angle theorem. And therefore, the measurement of angle 4 is going to equal 55. And so we have our answers right here with an easy explanation. So let's apply some algebra. Angle 5, we know is going to be 2x minus 10. Angle 7 is going to be x plus 15. So we have one option here. Okay, we know that the measurement of angle 5 is equal to the measurement of angle 7 because of the corresponding angle postulate. So if we know that they're going to be the same, we can say that this is going to be 2x minus 10, which equals x plus 15. And so let's do some math here. We're going to subtract the lowest amount of x's from both sides. We're going to end up with x minus 10 equals 15. All right, we're going to add 10 to both sides, and that tells us that x is going to equal 25. We can check the measurement of angle 5. is going to equal 2 times 25 minus 10, which equals 40. And we can say the measurement of angle 7 is equal to 25 plus 15, which also equals 40. And so they are both the same. So that's going to be our final answer. Let's try using one of the other theorems. Let's label it. Angle 4 we know is 4y minus 25. 8 is 4y. Now the measurement of angle 6 we can say is equal to the measurement of angle 8 because of the corresponding angle postulate. So therefore we can say that this is also equal to 4y. And so we can say that the measure of angle 4 plus the measure of angle 6 is equal to 180 because they are a linear pair. And therefore, the measurement of angle 4 plus the measurement of angle 8 equals 180. As you can see, what I did here was I said, we have this 6, we have this 6, and I took this, and I just substituted it in. So now I have that. It didn't change anything, but what we can say now is that we have 4 times y minus 25 plus 4y equals 180. 4y minus 25, oops, 100. We distribute, plus 4y equals 180. We end up with 8y minus 100, which equals 180. 8y equals 280. Therefore, our y is equal to 35. That's it. Thank you for watching. Make sure you bring your notes to the next class for credit. Mahalo.